appreciate you all coming out down here and talking with me about this. I really think we are at the leftmost part of infrastructure. Packer images are powering everything you do, and people don't even know it exists sometimes, but obviously you all do. And we talk about Packer, and it's usually about talking about a unified workflow. It's not just Packer or HTTP Packer, it's Packer and Terraform working together to create this unified workflow. And what does that workflow look like? Obviously, we start with Packer core, as we always have building artifacts, whether these are machine images or containers, some kind of deployable artifact, but then we have to release that to our downstream consumers. And finally, of course, we have to provision artifacts, and at HashiCorp, when we talk about provisioning, we're going to talk about Terraform. Now, a little bit about the build workflow. Of course, you always hear HashiCorp, workflow, workflow, workflow. I've been with HashiCorp now for almost 4 years this month, on Terraform mainly for my first 3 years, but the last year I've been really working with the Packer team, trying to bring HTTP Packer to market. And I really think it is the most workflow-centric product we have at HashiCorp. And we talk about the build workflow. First of all, 2 million downloads in the last 12 months. Packer has been around for so long, we don't talk about it. But it's going and going and going, and it just works. You don't see the 100 million downloads from Terraform here because we're a small group, and we're doing big things, but we do them quickly. Now, moving ahead, talking about the community and what's happening, of course, just like Terraform's provider system, we have an ecosystem with Packer. Over 48 plugins are now in that ecosystem, ranging from major clouds like AWS, Azure, and GCP, to DigitalOcean, Parallels. Any kind of artifacts that you need to build, we now have a plugin looking for that. Now look at these three right here is I think a really key thing that's happening inside the ecosystem right now. As we move to standardize and mature it, we're talking with the partners, and partners are actually taking over the development of these plugins, whereas they were all managed by HashiCorp before. You might have noticed something in the code base if you follow the PRs, where we're breaking these out and making it so they can be loaded individually, much like you do with plugins, or excuse me, providers on Terraform. And here we see VMware, DigitalOcean, and Linode this year all taking over ownership of their plugins, becoming verified, and creating that relationship. But what is the community for, and what are we all trying to do here? It really is going back to that unified workflow, whether we're talking about in the public cloud or the private cloud. Having that single interface to artifacts and fetching them and releasing them is very key for you all to standardize as you try to do the hybrid cloud. Now, another thing we're seeing a lot of right now is security is shifting left. We saw this first with the invention of SecOps, but really we're almost seeing that disappear and come into DevOps. And we're talking about Packer, of course, we are at the furthest left there is. And so what we're seeing is the community is shifting along with this. They're seeing the need to have tooling directly in the build pipeline to automate testing, whether for compliance or governance reasons or security. And I'm really happy to say, we have a new friend at Packer. Say hello to Mondoo. It's the first community release plugin specifically for securing your artifacts during the build process. As you see here, it's available on GitHub, still at a 0.3, but we're moving and moving here. But what this allows you to do is protect your supply chain, again, at the furthest left as we go. We can keep these compromised artifacts from ever reaching your organization. So instead of having to do this after the fact through manual processes and dealing with spreadsheets going back and forth between your security teams, we can build this directly into the pipeline. They have the ability to set a specific score threshold to meet your company's risk tolerance. So maybe we don't want anything coming in and we set this to 20, but more than likely we have something like an 85 and we let those small things come in, but we make sure that we never introduce any large incidents into our supply chain. And of course, as with everything with HashiCorp and our partners, this is available as open source as well, available today on GitHub. I encourage you to check it out. This will work with any of your existing Packer pipelines that you have today, and works with HTTP Packer as well. And this is really about creating that secure foundation for years to come. Not just talking about actual security here, but when talking about Packer Core and the team behind that, we want you to be able to rely on Packer for years to come. You know, we are making the transition from virtual machines to containers. However, VMs are going to be here forever. And we want to make sure that you can rely on Packer to keep those build pipelines coming. And so what you're seeing is us maturing our processes to make sure we can keep up with community demand. We're working towards Packer 2.0 next year, which will bring better support for HCL, more Terraform-like experience. So when you go in there and come between the two, it's acting as you expect it. We really want it to quack like a duck and not be kind of a side note. to the Packer story. Now that's Packer Core, and Packer Core has been here for a long time, and you obviously love it or you wouldn't be here today. But now we've introduced HC Packer this year. Again, a big year for Packer as we move to commercializing the product and making sure it's here for years to come. And a little different from the way we worked with Terraform is instead of just saying you have to bring everything into us and we'll run all your builds and all your pipelines for us, we wanted to make HC Packer an additive process to what you already have today. So if you're not familiar, you go into an existing Packer pipeline, you add a couple environment variables, and as soon as you do that, you start pushing up information directly to the registry about every iteration you build in those pipelines, giving you complete visibility across it. But when we talk about release management and HC Packer, the real thing here is channels. This is the secret sauce that engineering came up with that simplified the release process. So instead of having to manage all these different things, we have the ability to push up an iteration to a channel and make that available. But if we need to pull it away for any reason, whether it's security or it's just depreciated, we can do that easily by just revoking it from that channel. But this is actually a bit of a complicated process, and we're having customers going through these steps and not understanding what to do. So first we have to create a successful iteration. We all know how to do that already with Packer build, but we do have problems just getting it connected to the registry. But then after we get through that, we have to create a custom channel either via the UI and API. We have to understand what these channels are and why they exist. And finally, yet another call where we have to publish an iteration to the channel. It's a lot of steps for something that everyone is doing the exact same thing. So what we want to do is try to make that simpler for you all. And so today I'm happy to announce the latest channel. This is a new channel that will be automatically added to every bucket that you add to HCP Packer. What will happen now is we're going to manage the life cycle of this channel for you. So if you build a new iteration and once it's successful, we'll automatically publish it up to that latest channel. And it actually works the other way too. If you go in and revoke an image, we'll do automatic rollback for you and make sure this is always pointing at the latest successful iteration. Now we have some customers can actually use this production where they built things like Mondoo and others into their Packer build pipeline so they're confident once that build pipeline is finished, this is ready to go to production. But you could also see this being used in dev or staging and being able to automate those pipelines off of it. Again, just reducing the amount of steps in the workflow and getting you to the value quicker. So many buttons on this clicker. We have to get to the right space. Again, we revoke that channel. You can see it here moving between. I know the wording is a little small on the screen, but as we revoke that channel again, the iteration goes back to the latest. Now again, this is all really about the unified workflow. Packer, of course, can stand by itself, but the real magic comes when you put these two together and complete that entire circle that we looked at before. And it really is better with Terraform. Obviously, Terraform is the multi-cloud workflow for provisioning. What we've done here over the last 3 or 4 months is after gaining feedback and taking initial HCP Packer to market, we were hearing problems of Terraform users just not understanding why things were working. Essentially, it was not idiomatic Terraform. The workflow had thrown different pieces off. One example of this was with the run task. The run task, again, is something we put in between our plan and apply, and it can check to make sure all the artifacts that are being used are compliant and ready to use. Excuse me. And what we did there, but it would block changes. So if you had a load balancer, for instance, and the EC2 underneath that was using a machine image, you couldn't actually change the unrelated infrastructure. So if you need to change something on your load balancer, we would block those changes because you were using a compromised image on an already provisioned infrastructure. And what we'll now do is warn your users instead. So we won't block those changes. However, we do warn them that they need to rerun and update their Terraform for their base image. But again, just like Packer, this is really the multi-cloud workflow. You can create one image template, spread it out between the clouds, and it really is this easy from Terraform to provision that. Now, continuing on the idea of just making the product easier to adopt inside your organization, we're bringing this HCL builder for Terraform users directly inside the registry. So you kind of have two use cases inside the registry. We have you all most likely as the admins, the platform owners that are building and distributing these images, but we also have the ability to send this out to viewers as well, allow them to use it much like the Terraform registry, define which artifacts are available within your organization. And now we're going to make it even easier for them to consume. So you can see here form fields where you can go in and select which channel you're going to use. Here we're looking at the latest again and seeing what iteration is coming. But they actually have the ability just to do drop down the cloud provider and the region, all the necessary pieces to actually have production-ready Terraform. And with a simple click of the button, they can copy that and take it out. Now, when we talk about Terraform, obviously provisioning, but back in June at HashiConf EU, we introduced drift detection, which introduces this new workflow, the check, detect, and notify, essentially monitoring your infrastructure at all time for changes, whether intentional or not, and making sure you are notified of them. And of course, once we receive that notification, we want to remediate that change, whether that's changing our config to match what the real world is, or doing another plan and apply to bring out of bound changes. And just a little bit of Terraform here, since you all did skip the other meeting that's going on in the other room. They're introducing continuous validation to continue the story. I always say continue when I talk about continuous validation. But we talked about drift detection. What we're doing there is looking at the state as a whole and seeing if anything is different. And what continuous validation is doing is building on top of post conditions that we added in Terraform 1.2 that allow you to check specific resources and make assertions about that. It could be for security reasons or developer experience as you're writing modules to make it easier for people to consume. But now with continuous validation, we can continuously monitor these assertions and make sure they are true. And just like with drift detection, where we'll alert you when we notice a change, we'll do the same on continuous validation. And here we see it being used with HTTP Packer to make sure that you are always using the latest image. And so what we do here is, here you see on the top, we're referencing the AMI from the data source from Packer, trying to pull in that latest. And then here we have a post condition that's simply checking to make sure that AMI is matching the latest that's coming out of the data source. Of course, when you do your first plan and apply, these will always be true. However, later on, these could become false. And what we'll do here is notify your users and make sure they know that it's time to remediate. Now again, when we talk about remediation in HTTP Packer, this is code-free changes. All we really need to do is go back and fire off that plan and apply. We can even automate it, as you'll see here later. And once you do that, it's automatically going to bring in that latest compliant image and rebuild those VMs. But day 2 also is happening on Packer as well. And so we have new day 2 operations coming for HTTP Packer, specifically one-click rollback. Today you can actually do this if you want to keep a separate database from the registry and track your own channel promotion history, which I think one of you has done, but nobody else. And so what we want to do is bring this into the application. So first, we're adding channel promotion history. You'll see this actually on all standard plans as well. We'll have a limited view into it, but our plus tier will have this complete view of everything that's ever happened with a channel. And once we have that information, now we can empower one-click rollback. You can imagine going into a single iteration, or a channel, excuse me, and rolling it back. But we also can build this on top of revocation. So now if you go and revoke an iteration, instead of having to go through the multiple steps of bringing it off the channel, revoking it, publishing something else up to the channel, we can do that all for you at revocation time. Now we looked at build, release, but now what we're going to do is add webhooks to the release process, allowing you to build these bespoke workflows that you need that are specific to your business. I see one head nodding in here because we've talked about this in depth. But we want to be able to integrate with all the tools. Obviously, you're not always going to use Terraform for every operation, and we want to be able to build into the community. So we might send this out to Terraform to be able to do a plan and apply automatically. We might send this out to GitHub, where we have a GitHub action that's building off a child image, and now it knows another image is out there and it can rebuild itself. Again, just locking into the computer and allowing you to have that extensibility inside HTTP Packer to integrate into your existing systems. Now, going back to the build workflow for a second, and I kind of teased it a second there when I said about the child images. Here's what we've always been talking about for the last 6 months on HTTP Packer, which is the golden image factory. You as a platform team, maybe you're pulling in some pre-seed information or maybe an external artifact from the cloud that you're basing it on, but you're adding your own security and hardening, maybe some logging infrastructure, and this is what you're going to distribute out to the rest of the company, and then they're going to consume these images for your Terraform or something else, and then layer on their applications with Ansible, after provisioning. But what we can also do is actually bring this into the build workflow. And so you've always had the ability inside Packer to base your image off of another image, but now we've integrated that with HTTP Packer as well, bringing a data source, as you'll see here shortly, to Packer that allows you to fetch the latest compliant image, bring that down, and use that as a base image. And as you see here, this all gets put into, and then with Packer, as we know, we can spill this out to the clouds. We can have AWS, 2 different regions. We can actually have it going to Azure and GCP, all from the idea of having that unified coded template. So I'm very, very happy to say that we're introducing ancestry tracking today. I just got the notification on Slack about 15 minutes ago that this is now live in HCP Packer. Again, giving you visibility into your entire fleet of immutable infrastructure. You have the ability to see both from a parent and a child the dependency statuses. Here you'll see a few that are out of date where their parent has published up a new version to the stable channel, and now they understand that they need to be reran. Again, this will all play back into webhooks that we were talking about before. When we see these parents change, when we see dependency status changing, we fire out the webhook. We can trigger rebuilds. We can trigger plans and applies. It is here, and it all, again, starts with this data source. So you're familiar with how data sources work in Terraform. The similar idea is now in Packer. Here we're looking at the HCP Packer image, which, by the way, we did simplify this as well, making it instead of a number of different blocks of code, you can do the single code and pull in the latest image, and as you see below, source your AMI on top of that. This allows you to make sure these immutable infrastructures are always up to date, which is a very hard problem today. We go into customers who are doing this at scale, yet they have no visibility. So when you have a problem, when you need to revoke something, say there's a security problem, you have no idea where it is. Again, now we can track this dependency status across all iterations. And this is actually supposed to be out about 6 weeks ago until we saw one key piece that we were missing. How do we understand which one you are really based upon? And if we think back to that data source, since we're always fetching via channel, we know that's where your dependency lies. So if that channel has changed, whether you're based on the stable or a staging or even that latest that we were talking about before, as soon as that changes, we can start alerting downstream consumers that a new base image is available. Now stepping back again to the immutable workflow here and looking across, we have our common image and we have our billing app out there, and maybe even the marketing team has gotten onto the play. But what happens if something gets in that pre-seed? I think we've seen this over CodeCov and Log4j, but our dependencies that are coming from outside, they're not always trustworthy, and sometimes this is going to happen. And how do we come back from this after this has gone through our billing app and out to our marketing project, and then, of course, gotten to the clouds themselves? How do we bring this all back and get back into a compliant state easier? I've talked to customers, and they're relying on emails and spreadsheets, and I don't mean Google Sheets. I'm talking Microsoft Excel sheets, version 2, version 5, version 7, X'd out, marked out, email chains. So what we're bringing, along with ancestry tracking, is multi-level revocation. So now you can revoke all those downstreams easily in a single action, whether via the UI or API automation. Of course, depending on your organization's needs, you might not want to do this. You might not want to force everyone, or it might depend on the level of the incident. So we have that option of only revoking the parent or revoking everything down chain. Again, talking about webhooks and how this can play together. You can automate immutable workflow all the way down. We've also been listening to our customers and seeing what they need to adopt Packer at scale and how to integrate HCP Packer. And so on HCP Packer, we've been working on official support for JSON templates. You can actually use JSON today, however, it's not very well documented, and it really wasn't something we had planned on supporting, to be honest with you, as we do see the future of being HCL, specifically when speaking with the registry and being able to add custom metadata. However, there are so many pipelines out there today that are using JSON already, whether just for legacy reasons, because like we were saying before, it's just been working for 8 years and it's fine and we don't need to change it. But usually we see this more so when there's a big piece of automation built around Packer, and that automation is what's building out these templates. And we want to bring the ease of use of the registry to these customers that are running the scale. So I'm happy to say with only a few environment variables, again, in those pipelines, you can now add which bucket this should be tracked to and immediately start tracking these JSON templates as well, avoiding the need to migrate to HCL in order to gain that visibility. Kind of a checkbox feature here, but if you're a large enterprise, you need to know what's happening with all your infrastructure, and you need to be able to audit that when the time comes. Audit log streaming built on top of the HCP platform is coming soon. We should see a beta of this here in the next few weeks, and then in Q4 rolling out more widely. Again, starting with Datadog and AWS CloudWatch, then moving on to Splunk and other cloud-native logging solutions, giving you the ability to stream everything that's happening to the systems that you're already using, right? We want to make sure always at HashiCorp that we can work with the tools that you're using, that you want to use, and not force you down a certain path. Now, why is it important to meet enterprises' needs? Because of the supply chain security. And I say cue the goosebumps because I literally got goosebumps when I was writing these slides, because I really think from these numbers here, and you'll see, last year, 300% increase in software supply chain attacks in 2021. 300%. I didn't put the 2022 number because I just didn't want to scare you, to be honest. But this is what's happening out in the real world. 82% of CIOs feel their software supply chain is vulnerable. And I'm guessing the other 18% don't know what software supply chain is, to be honest. Because when we talk about this, it's a very large problem and an unsolved problem. But I do believe this is where we can change the world, where we can make security easy enough to where we can bring it not only to the big enterprises of the world, but to every Packer user, every Terraform user, making sure they follow baselines of security, making the world safer. And I say we, because I don't really believe it's HashiCorp's job to do this. It's the community's job. The community will come together and decide what we need to do. And SALSA, which is supply chain level something, you'll excuse me, I just call it SALSA all the time. I always forget these 4 words. But this is a community-developed framework for reducing software supply chain risk in the real world. I think the key word here is reducing. We're never going to get rid of this, but we need a pragmatic path to reduce our exposure, right? And I say the real world because this is where these ideas are coming from. The steering committee consists of members from Google and Intel and Citi, seeing exactly how their supply chains are being attacked and what the steps they could take to be more robust. And again, why I really like SALSA is because they don't tell you have to do these 1,000 things and say, if you don't hit 2 of them, you're invalid. They've given us a pragmatic, iterative path to risk reduction. And why we need that, again, is we have this entire supply chain, and then we have all these places where threats can be injected. Of course, we play in the build and package area here with Packer and Terraform. However, we do believe shifting this to the left can increase the security posture across all of our customers. Again, I encourage you to check this out at salsa.dev. Just an amazing framework, and we'll walk through a little bit right here. Again, all about that pragmatic, iterative path to risk reduction. Now on level 1, again, I go level 1, level 2, level 3 on the SALSA certification. The build process must be fully scripted, automated, and generate provenance. Now, I think we understand scripted automated builds pretty well in Packer land. This is infrastructure as code. We've been doing this for years. Level 2 requires using version control. I think we've heard of this before. And a hosted build service that generates authenticated provenance. And this one gets a little wordy, but the source and build platforms meet specific standards to guarantee the auditability of the source and the integrity of the provenance. I think you'll start noticing what I'm bolding here, but it continues. We want HCP Packer to become your source of truth for artifact provenance. And this is really a lot of the feature work that's happening now beyond what we've seen here. These are small additions to the metadata that goes into systems, but combined, all of them together allow you to establish artifact provenance, which is the foundation of software supply chain security. Here we're talking about bringing in more metadata from the CI/CD pipeline so you know exactly which run triggered, iteration authorship, either via directly in the HCP users or going down into your VCS users and bringing that information up, build times, exact timestamps, and how long each ran was happening, and finally that idea of bringing external artifacts into the system. When you're building these base images off of cloud-provided images, we need to bring those into Packer. Currently, we have no visibility into that, so we want to be able to follow this chain all the way back to where it started, and again, all about becoming that source of truth for artifact provenance. So I think you all know we did go public this year, and there's been many legal ramifications because of that, so I had a lot of slides removed from my deck here. So we'll have to talk in more friendly terms. But I think you can see where this is going. If we can establish that provenance inside the registry, that gives us a central place to put on top of governance and other controls on top of this. And when we add that with Terraform, again, we come back to that idea of the unified workflow, going all the way from the left of building these artifacts, getting them out into the infrastructure, and having it provisioned. Again, thank you all for coming here. I think there's a much bigger crowd downstairs. I think we're more friendly here. I encourage you, we're not going to have time for Q&A right now, but I'm going to be right outside the hall. Please just come out and reach out. Again, I think it's an exciting year for HCP Packer, and the future for Packer is very strong and bright. Thank you all for coming out today.